Hello viewers, you're welcome once again. We're still under logic, cried Almighty God's algebra. Today we are going to treat law of distribution. Law of distribution. We have law of distribution by conjunctive statement and law of distribution by disjunctive statement. But we're going to start with law of distribution by conjunctive statement. Let us start. Law of distribution. P and bracket not P or Q is equal to bracket P and not P or bracket P and Q. This is a typical example of law of distribution by conjunctive statement. This principal connective that connects the first conjunct P and the second conjunct not P or Q makes it to be conjunctive statement. So because it is a conjunctive statement, that's why it is law of distribution by conjunctive statement. So we're going to prove this example of law of distribution so that we can prove that law of distribution exists. Let us start. Proof. Suppose P and bracket not P or Q is equal to bracket P and not P or bracket P and Q. We assume that the statement is true and is a hypothesis. So we're going to prove that it is true. So we assume that it is true that P and bracket not P or Q is equal to P and not P or P and the Q. Now, in this statement, you see that whenever the left-hand side of the equation is true, also the right-hand side of the equation is also true. And whenever the right side of the equation is false, also the right side of the equation is also false. We say that it is logical equivalent. That means they are equal. The equation is equal. That means they are equal to each other. And if they are equal to each other, we say that it is law. But if one is greater than each other, but one is specific to each other, we say that it is grace. So if it is true that the left side of the equation is equal to the right side of the equation, also this also must also be true. If and only if P and bracket not P or Q, if and only if bracket P and not P or bracket P and the Q is tautology. Now, this statement, this our assumption has now been transformed to conditional statement. So we say that if it is true also this also is true. In the sense that whenever the left equivalent is true, also the right equivalent is also true. Whenever the right equivalent is false, also the left equivalent is also false. If we evaluate this statement, there's no possibility of getting falsity, always truth. You say that it is tautology, being justified by logical equivalent. Being justified by logical equivalent. So if this is also true, this also must also be true. If and only if P and bracket not P or Q implies bracket P and not P or bracket P and the Q is also is tautology. Now, this statement has now been transformed to conditional statement. This biconditional statement has now been transformed to conditional statement, and it still preserves tautology. That's why you say that how is it preserve tautology? Whenever the antecedent is true, the consequent must also be true. In this statement, whenever antecedent is true, also the consequent must also be true. So if this statement, if you reflect it, there's no possibility of getting falsity, always truth. You say that it is tautology. Being justified by logical implication. Being justified by logical implication. Now, since this is true, also P and bracket not P or Q, that is the antecedent, is a logical implication of the consequence. That means the antecedent is a proper implication of the consequence. By the principle of logical implication, we then say that P and bracket not P or Q is a logical implication of bracket P and not P or bracket P and the Q. So it is true that P and bracket not P or Q is a logical implication of the consequence. So by the principle of logical implication. If and only if P and bracket not P or Q is logical implication of bracket P and not P or bracket P and Q. So we have now derived that P and bracket not P or Q is logical implication of bracket not P and not bracket P and not P or bracket P and the Q. So if this is true, also this also must also be true. If and only if P and bracket not P or Q is equal to bracket is equal to P and bracket not P or Q. That means the logical implication is equal to itself. It is true that logical implication is equal to itself, because whenever the left hand side of logical implication is true, also the right hand side of logical implication is also true. In the same vein, whenever the right hand side of logical implication is false, also the left hand side of logical implication is also false. We say that it is logical implication. So it is true that logical implication is equal to itself because it is logical equivalent. It is still law. So that is why we say that logical implication is equal to itself, being justified by identity. That means the sameness. That means they are the same. So they are equal to each other. So being justified by identity. Being justified by identity. Say if and only if P and brackets not P or Q is equal to bracket not P or Q upon not P. Is intensification of P and bracket not P or Q. That is that you see that this statement, this quantitative statement has now been transformed to conditional statement by Christ Almighty God's grace. You see that the right answer of the question now is no more equivalent to the left answer of the equation now. The right answer of the question now is now increased in value. It has now been intensified. It's now increased in value. That means it's now a facet of the left answer of the equation. It's no more law now, it's now grace. Because they are not logical equivalent. Rather, one is greater than another one. That means one is facet to another one. We say that it's intensification of the left hand side of the equation. So be justified by Christ Almighty God's grace. Christ the Almighty God's grace. If and only if P and brackets not P or Q is equal to not P upon not P or Q upon not P. Now you have seen that you have not distributed this implication not P between not P or Q. That's why you have not P upon not P or Q upon not P. And it's still intensification of the left hand side of the equation because the right side of the equation is still increased in value. It's still greater than the left hand side of the equation. We say that it is intensification of the left hand side of the equation because it is tautology. It is tautology. Here it is not P or Q. Why here is P and the Q. So it's still intensification. Here is still intensification because here is P and Q and here is tautology. So you say that. So we split this not P between not P and the Q by distribution of implication. By distribution of implication. So you say is intensification of P and bracket not P or Q being justified by distribution of implication being justified by the of implication. So if and only if and only if P and bracket not P or Q is equal to, we are going to revise this statement not P upon not P. That means the conditional statements not P upon not P or Q upon not P. That means not P implies not P and not P implies Q. We are going to revise it to conjunctive statement. Reason is that this not P is being generated from conjunctive statement P and bracket not P or Q. So when you want to revise it, it's going to be in conjunctive statement. That means we're going to have P and not P or bracket P and the Q. So we have now revised it to conjunctive statement, and you see that it's now equivalent to, it's no more grace now, it's now a law now, because the two sides of the both sides of the equation, they are now equal, they are now logical equivalent. So it's now law and they are now equivalent, being justified by, because it's through Christ Almighty God's grace will transform this statement, this question statement, to conjunctive statement. So, being justified by Christ the Almighty God's grace. Being justified by Christ Almighty God's grace. We continue to this side. We have now proved that P and bracket not P or Q is equal to bracket P and not P or bracket P and the Q, which is setting as this. So we have now proved it. But before we established that P and the bracket not P or Q is equal to P and not P or bracket P and Q is law of distribution by conjunctive statement, you must prove the converse. So before then, we say, then conclude, he said, thus, P and bracket not P or Q is equal to bracket P and not P or bracket P and the Q. So I now prove the hypothesis, our assumption that P and bracket not P or Q is equal to bracket P and not P or bracket P and the Q. I proved the assumption. Now I'm going to prove the converse so that we then establish by the principle of externality, we then establish that P and bracket not P or Q is equal to P and not P or P and the Q. Is law of distribution by conjunctive statement. So he said conversely, bracket P and not P or bracket P and the Q is equal to P and bracket not P or Q. Now we see that the left side of the equation here has now become the right side of the equation here. The right side of the equation here has now become the left side of the equation here. You see that it is converse. So we're going to prove the converse, we then assume that the statement is true. So we say that suppose bracket P and not P, or bracket P and Q is equal to P and bracket not P or Q. So we assume that statement is true, and we say that whenever the right answer of the question is true, also the left answer of the question is also true. Whenever the left answer of the question is false, also the right answer of the question is also false. We say that it is equivalent, it is equal. That means the equation is logical equivalent. That means they are equal. So if this is true, also this also must also be true. You're going to transform it to biconditional statement. You see, if and only if bracket P and not P, or bracket P and Q, if and only and only if P and bracket not P or Q, or Q is tautology. You see that we have now transformed this assumption to biconditional statement and is true, because whenever the left equivalent is true, also the right equivalent must also be true. Whenever the right equivalent is false, also the left equivalent must also be false. If you write this statement, there's no probability of getting falsity, always truth. You say that the statement is tautology, that it is truth. So if this is also true, this also must also be true. Then we're going to transform this biconditional statement to conditional statement, and it will still preserve tautology. That means if and only if bracket P and not P, or bracket P and Q implies P and bracket not P or Q. So before then, this is being justified. It's being justified by logical equivalent. It's through logical equivalent. It's through logical equivalent that we transform this statement to biconditional statement. So you say being justified by logical equivalent. So through logical equivalent, we transform this statement to biconditional statement. So we're going to transform this also to conditional statement, and it will still preserve tautology. So if and only if bracket P and not P, or bracket P and Q implies P and bracket not P or Q is tautology. Is tautology. We see that we have now transformed this biconditional statement to conditional statement, and it is truth, because whenever antecedent is true, also the consequence must also be true. So in that case, if you write this statement, there's no possibility of getting falsity, always truth. You say that statement is tautology, being justified by logical implication. Being justified by logical implication. You go to this side. So if and only if and only if P and not P, or bracket P and Q is equal to bracket P and not P, or bracket P and Q. Sorry, not yet. You see that this statement, that is tautology, they are going to derive that this is a logical implication. I mean, this antecedent is a logical implication of the consequent. This logical implication, this antecedent is logical implication of the consequence due to the antecedent is proper implication of the consequent. That means this is a proper implication of the consequence. So by the principle of logical implication, we then derive that this antecedent is logical implication of the consequence. So if and only if bracket P and not P, or bracket P and Q is logical implication of P and bracket not P or Q. So we have now derived that antecedent is logical implication of the consequent. If that is true, also this also must also be true. Say if and only if bracket P and not P, or bracket P and Q is equal to bracket P and not P, or bracket P and Q is equal to bracket P and not P, or bracket P and Q. That means the logical implication is equal to itself. Logical implication is equal to itself, and it is true that logical implication is equal to itself because they are logical equivalent. In the sense that whenever the left hand side of logical implication is true, also the right side of logical implication is also true. In the same vein, whenever the right side of logical implication is false, also the left side of logical implication is also false. We say that it is logical equivalent. That means they are equal. It is true, they are equal. Being justified by identity, the sameness. By identity. So if and only if bracket P and not P, or bracket P and Q is equal to, we are going to transform these statements, these conditional statements, so these quantitative statements to conditional statements. The two quantitative statements, we are going to transform them to conditional statements. That we're going to have not P upon not P upon not P, or Q upon not P. We have now transformed them to conditional statement. That means not P implies not P, or not P implies Q. Now, it's not intensification. It's no more now law. It's now grace, because they are no more equal to each other. The equation is no more equal to each other. Rather, the right side of the equation is now greater than the left side of the equation. That means the right side of the equation is now supersede of the left side of the equation. We say that it is intensification of the left side of the equation. You say is intensification of bracket P and not P, or bracket P and Q. Now it's now intensification of the left hand side of the equation, being justified by Christ Almighty God's grace. Because through God's grace, that will transform all these conjunctive statements to conditional statements. Being justified by Christ the Almighty God's grace. If and only if bracket P and not P, or bracket P and Q is equal to, you see that this not P and this not P, they are distributed between not P or Q by the sort of implication. By the sort of implication. That means it is not P or Q upon not P. So this not P is between not P or Q. That I have not P upon not P or Q upon not P. And it's still intensification of the left side of the equation. Is intensification of brackets P and not P, or bracket P and the Q, being justified by distribution of implication. Is through sort of implication that we have these two. By being justified by distribution of implication. We continue to this side. If and only if bracket P and not P, or bracket P and Q is equal to P and bracket not P or Q. Now you see that this conditional statement has now been revised to conjunctive statement. Now this not P or Q upon not P That means not P implies not P or Q. That is, conditional statement has now revised to conjunctive statement. Reason is that this not P, this not P is being generated from conjunctive statement. That means this P and not P and P and the Q. So we generate this not P from conjunctive statement. So whenever I write it, it's going to be in conjunctive statement. That's why I have P and bracket, not P or Q. And it's now equivalent to the left hand side of the equation. So it's now law. And you have now proved the converse. So it's been justified by it is through Christ Almighty God's grace that we transform this conjunctive statement to conjunctive statement. So be justified by Christ the Almighty God's grace. So we have now proved the hypothesis, that's our assumption, that the converse P bracket P and not P or bracket P and Q is equal to P and bracket not P or Q. So we have proved the assumption. The converse, we have now proved it. So by the principle of externality, having proved the converse, so by the principle of externality, we then establish that P and bracket not P or Q is equal to bracket P and not P or bracket P and Q is law of distribution by conjunctive statement. So we then conclude, therefore P and bracket not P or Q is equal to bracket P and not P or bracket P and Q. So we have proved the law of distribution by conjunctive statement exists. So having proved the converse, it then establish that the law of distribution exists. So at this juncture, we shall draw our curtain. Thank you, viewers.